Okay, this is a problem from the Chapter 4 review that I was asked a question about. We're asked to find the limit as x approaches 0 of 1 minus 3x raised to the cosecant x. Now, when I see a problem like this on a test, especially a chapter test, or really anywhere, I think about the rules that we've been presented with that may be tested at this point. And of course, as far as limits go in this chapter, we use L'Hopital's rule to help us with limits. So I need to look for a way to actually apply L'Hopital's rules to limits. So, when I look at this, if I plug in 0, I get 1 to the uh, undefined, right? Cosecant of 0 is undefined. So we can't take the limit there, but we can't leave it at that either. So because I have a variable expression as an exponent, I might think about using properties of logarithms to help me manipulate this expression so that I can evaluate the limit. All right, so I'm going to start by saying y equals the limit as x approaches 0 of 1 minus 3x to the cosecant x. Okay, and I'm going to take the natural log of both sides. So I can say natural log of y is equal to, you can go back and look at limit properties of compositions of functions, but basically this is going to be the limit as x approaches 0 of the natural log of 1 minus 3x to the cosecant x. All right, and now that I have that, I can use my log properties. Before I go farther, don't forget what we've set this equal to is natural log of y, and the actual limit that we need to evaluate is y. So we'll come back to that at the end. But for now, we're solving for natural log of y. And I can use my natural log power property. Okay, the natural log power property says if I have the natural log of m to some power, okay, that's equal to, and this is not just natural log, it's any log. We can rewrite that as the power times the natural log of m. Okay, so I can apply that here, and we have the limit as x approaches 0 of cosecant x times the natural log of 1 minus 3x. Okay, and we might think about it now. Cosecant of x is still undefined, but cosecant x is equal to 1 over sine x. Okay, times the natural log of 1 minus 3x. And so we get the limit as x approaches 0 of natural log of 1 minus 3x over sine x. Okay, now I can look at these pieces individually. That is the numerator and denominator. So I know that the limit as x approaches 0 of the natural log of 1 minus 3x is equal to, if I plug in 0, natural log of 1 minus 3 times 0, I can drop my limit notation because natural log of these finite numbers is going to give me a number. Okay, and so we get natural log of 1, which is 0. Okay, so the limit as x approaches 0 of my numerator is 0. And I need to look at the denominator, the limit as x approaches 0 of sine x. Well, I can plug in here as well. That's just going to be sine 0 is also 0. So we do get 0 over 0, and we can apply L'Hopital's rule. Okay, so if I take that derivative, and let me just write what we had again. We had the limit as x approaches 0 of natural log of 1 minus 3x over sine x. Okay, and so to apply L'Hopital's rule, I'm going to take the derivative of the top, still taking the limit of this. So the derivative of the top is 1 over 1 minus 3x times negative 3 over the derivative of the bottom, which is cosine x. Okay, and so cosine of x is 1, so that gives me a nice denominator. I can go ahead and plug zeros in. We get negative 3 over 1 minus 3 times 0 over cosine 0. Okay, or that looks like it's going to be negative 3 over 1, or negative 3. All right, and so from there, don't forget that what we have found to be equal to negative 3 is natural log of y. All right, so we need to figure out exactly what y is. Okay, it's natural log of y that's equal to negative 3. So to figure out what y is, I can take e and raise it to each side. So we're talking about e to the natural log of y equals e to the negative 3. Okay, I can do that because e and natural log are inverse functions of one another. They cancel each other out. So we get y equals 1 over e to the third power. And that would be how we could assess that limit.